Hi, my name is Tom Coolish. I work at ClearEdge IT Solution. I'm the chief architect here. So today I'm actually bringing you a conversation or a topic that's kind of fun. We're going to talk about Microsoft Flight Simulator 2020, super exciting, and how it actually works with Geo and how it works with the world of Geo and the technology behind that. So first, let's start with some history. Microsoft Flight Simulator, I don't know if many of you know this, it is actually Microsoft's longest running product. It's not Office, which is 1990. It's not Windows, which was I think 85. It's not even Word, which was 83. Microsoft Flight Simulator is its longest running product. The first one actually on the left that you'll see there is Flight Simulator 1. It was actually built off of an Apple II product that was built in 1979, ported to IBM PC. Flight Simulator 4 is the one in the middle. That one was built in 89. It has dynamic scenery, some roads, some ground traffic, and crazy for 89. And the small one over on the right is actually Flight Simulator X. I don't know if it was 10 or X. It was the latest one previous to this one, this generation's. So they had an actual SDK. You could go in there and actually edit things. It had ATCs, air traffic control, animations, and etc. So basically, 38 years later from number one, we are now here in this world for Flight Simulator 2020. I believe the actual name of it is. So I'm actually first going to start you off with a little video of actual game footage. So this is a video of me flying this craft, virtually obviously. It's a Beechcraft Bonanza G36. We're starting off in the world around ClearEdge's headquarter building. So as you can see, if you're looking at this, you can see the trees, you can see the buildings, the parking lots, the roads. In games, usually these are painstakingly architected or built or modeled on specific maps. I'll tell you exactly how it's being done, but I'm in a random place in the middle of Maryland, in which this is all being shown right now, and pretty accurate. You're actually flying past Route 32 right now, and I do know most of these roads. You're actually flying over some railroad tracks here. There's warehouses there. There's actual construction vehicle things. You're seeing this pretty amazingly in a good amount of detail, which I thought was pretty interesting. There are actually 4 buildings. There's a post office there in the back. Been there before. And now we're about to pass ClearEdge here in your lower right, and going directly underneath it. You can feel it's an interestingly shaped building. It's kind of like a weird angle. I don't think game designers went out and got ClearEdge and went like, we need to put that in the game. No. That is actually coming from some interesting places, which I'm going to show you about. As now I'm taking a turn to go fly back over 32, and you can see ClearEdge's building right there. The parking lots look perfect. The building looks exactly how it is. It's almost spaced perfectly from 32 is where it usually is. So it's pretty cool in that sense. So my usual next question is how did they do this? And that was actually the first thing when playing this game. I'm like, how did you do this? So in some research, I first found out that the entire Earth is done. The complete Earth. You can go anywhere on the Earth and you're going to get as close to accurate representation of that. They're using Bing.com or Bing Maps, which I found interesting, just in general, Bing, and other sources of data. And then they're also using the cloud, because that's a lot of data on your local PC. So they had to use some sort of cloud to help with building some of the features like terrain, tree, grass, buildings, water. So they're using Azure, Microsoft Azure's cloud-based offering to do these things. So yes, I did say Bing because that's kind of interesting. Bing in itself, actually, what made me interested in this is that I didn't realize how much data was behind it. So there's 2 petabytes of graphic or map data that is helping generate these sources. So there's satellite imagery, the 3D grammetry. So I actually had to look that one up. I didn't know what that was. It's actually an art or science. They call it an art and or science of extracting 3D information from photographs. Usually it takes your overlapping photographs of an object, a space, structure, and converting them into 2D and 3D models. Used actually a lot for your 3D printers. So they're taking that with doing also, Microsoft also got some flyovers of the world using LiDAR, which is a laser type radar, to increase some of the models that they had. They're throwing that into Azure and AI sources to analyze that data and create these 3D models for the game. And they're grabbing down to like centimeter level of precision. And all of that done is kind of in an offline AI procedural generation function, not going into terrible detail there. Also, they did specifically pull in human artists and computer modelers to better define certain areas, specifically airports. And then they have they're streaming that data actually down to the game. That's interesting. The photo on your right is actually the top one, I believe, is an actual photo from Bing.com, and the bottom one is one that's in the game. So here's the pipeline. The thing is I think this is the pipeline. I am not a Microsoft employee, and I do not have understanding of the proprietary information. But from what I've read and some of the articles I've driven into, I can see that they're basically pulling the data from the left, which is OpenStreetMaps, Bing Maps, LiDAR information, some more on-demand streaming things like current weather patterns, and also current live air traffic control, throwing that through the cloud using different types of AI. There's something called the Black Shark AI company, and they help create these like 3D maps. Their company do that. And then they're using also Azure's AI tools. That data is being funneled down into Microsoft Flight Simulator, and they specifically chose a game studio who specialized in graphic engines for huge virtual environments. They're actually out of Bordeaux and France. It doesn't seem like a bad place to be. Phil Spencer in February of 2020 actually made a comment when he said this. He said the competitors for Xbox, Phil Spencer works is the head of Xbox. He said the competitors' their interactive environment were no longer just the general Sonys and Nintendos, but the people they're competing against actually are Amazon and Google. So you could just see that the transition of moving away from just these console game systems as the main competitors. Now the cloud's involved in this. And here's an actual implementation of that. So, the funny part is, pulling from OpenStreetMaps and pulling from open source data, you can even have mistakes in your data. So as you see, there's a huge, large obelisk kind of in the middle of this flight thing, and in the middle of this city. It actually came from a university student. Nathan Wright was actually working on some stuff back in 2019. He accidentally mistyped a building's height. Instead of writing 2 stories, he wrote 212 stories. No one saw that until someone was flying Microsoft Simulator, which Microsoft Flight Simulator, which was using this data, and they said that building is not in that city. It's just funny that like small open source data can be seen that you never would look at in any other fashion is showing up in there. So I thought it'd be fun to actually show you some actual real terrain through the game that's auto and procedurally generated 3D model. So this is me flying through DC, through the Wharf, which is a newly built downtown area with a bunch of boats, cool restaurants, hotels. You can see East Potomac Park up there. You can see the tidal basin. This is all being generated automatically. From here, just decided I was like, hey, I want to go to Cambridge, Maryland, which if you've ever driven down Route 50, which is right below right there, to Ocean City, Maryland, you've driven through this city. And then from there, I was like, hey, I've always wanted to go to St. Michael's again, so let's fly by it. So I decided to just drive down and fly over the city right there. And then I tried to take a step out and like, let's go somewhere else in the world, because you can go anywhere in the world. So I went to Germany, and I went to a random place called Papenburg, which has I think I'm saying that right, they actually built ships there. So I was like, let's go over that. And then from there, I was thinking, what's another city I can go to? Amsterdam. Never been there, so let's take a fly around. All of these areas are automatically generated. All of these parts of this city these buildings are automatically generated and seen from above. And then I was thinking, I kind of really want to go to the beach. So let's take a flight down Siesta Key, Florida, and go see what that looks like from above. And from here, you can look and see the detail. You can see the spacing from the beach to actually the hotels. You can actually see, if you look close enough, you can see umbrellas that are generated from there. Enough city, I decided to actually also step back and say, let's go out into like the forest and look at, you can see the foliage, the tree coverage. That's Mount Rainier. in Washington State. But you can fly around all of these places, which is pretty awesome. Another thing that people are doing, which I thought was kind of awesome, people are actually going storm chasing because they're pulling in real-time data, not only air traffic, but other types of data like weather. You can actually pull up the current weather and see a hurricane and go fly into it. You can be a storm chaser. So this is someone actually on the internet that went after and flew into Hurricane Laura. I flew into a couple ones, but I figured just to show you a picture. You probably didn't see enough video. Overall, the metrics are astounding to me, and that's kind of what I'm going to end on here. And this game is pretty awesome. That's coming from data driven from the cloud to your local machine. It has over 197 million square miles of land and water. There's 2 million cities and towns, 1.5 billion buildings that look really almost down to centimeter accuracy. 2 trillion trees, 37,000 real world airports that you can fly into and land at. And from that, even if you turn up the detail level enough and your GPU can handle it, that you can see different species of birds, elephants, giraffe, bears, things that they've seen in pictures that are being modeled on the site. So overall, I believe this game is pretty amazing. It's using a combination of the cloud and geo to create a pretty authentic, real-world, entire Earth set. Thank you very much. If you have any questions, feel free to use the chat.